Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
As we continue to explore our dynamic world data set, it becomes more obvious, maybe not say the word obvious, but it becomes more interesting to work with the data set, simply because you're getting understanding of the power of the data set, of what you potentially can do with the data set. So you start from a very basic analysis or understanding of the data set, and as you work with it, a lot of opportunities or probabilities comes to light. So you go for the one door and a number of doors open. You go for another door, a number of doors open. Same idea, spider web methodology type of thing. So as I said, we're working with the dynamic world data set, which specifically uses the Sentinel images as its base. So you use the Sentinel images, and the methodology using that Sentinel images creates a land use, land cover classification for your region of interest, which is quite neat. So yeah, so it's interesting stuff. So we, in the previous video tutorial, we then looked at this particular scenario, which we said, okay, we want to isolate or identify those locations within our region of interest which didn't have any land cover, or there was a 20% whatever probability that there weren't land built-up areas or built-up footprint. And now, X years later, there are 70% or 60% probability that there is a built-up footprint there. So this is what we then generated. So we're still, in one way or another, doing change detection. In this case, built-up. And just different isolating or identify certain things around the change detection or the land use, land cover patterns of my region of interest. And that's just said based on the dynamic world data set and the underlying Sentinel daytime images. Yeah. So what we're now going to do is to say, okay, remember in our cases with this one here, this what we've done there, and this one, to a large degree our quantification, and this one here, we're looking at two periods. We're looking at the beginning period, and we're looking at a ending period, and that gives us our change detection. So we visualize the land use, land cover in about beginning period as defined by yourself, and then we're looking at the land use, land cover at the end period as defined by yourself, and we're looking at those two absolute points and then see, okay, how does the 2 points differ from one another? What happened over this period of time? So that's typically what we've done. It's fairly accurate, I would argue. It's not going to give you too much problems, but you work with two extreme points, a beginning and an end. So in our case, let's say we're working with 2015, and let's say as our beginning period, and 2023 as our ending period. That gives us 8 years between that. And so when you're just looking at 2015 and 2023, you may miss the dynamics or the intrigues or the characteristics of what may have, may not have happened throughout the period. I said, let's say, for example, you worked with 2021 data. I mean, then you would have been smack bang in the middle of COVID. And that would give you quite a wrong impression or wrong analysis because it's an outlier period. So there is problems or there is concerns that you should note when working with two absolute periods, and you don't include what happened between those two periods, because that may be there may be vital information or content within that as well. So what we want to do is to say, okay, yes, we've got a beginning period and an ending period, but we also want to look at what happened throughout this period, what happened from 2015 to 2023. What happened in 2016? What happened in 2017, 18, 19, and so forth, and so forth. Okay. So that's going to be the focus of the current video, this particular video tutorial. We're going to create a time series for each class spanning the whole period from 2015 to 2023. So it won't be just two extreme points or points in time, i.e. 2015 or 2023. It's going to be a continuous information, a continuous time series between 2015 and 2023. How many images there may or may not be, and we'll determine those things now. Okay, so that's the whole idea of this particular video tutorial, is to create a time series for each and every land use, land cover category or class. Remember, there's 9 classes. Let's just confirm that there's 9 classes. So we want to generate a time series for water, trees, and each of these one over the period. So that will give you an indication of what happened with water. So you may be able to identify periods where it was very wet or very dry, or trees or grass, whatever the case might be. So it will not just indicate two extreme positions, but a continuous flow of information of data. So that's what we want to do, is we want to create a probability class for each, or probability value for each and every class throughout this period. So first of all, as per normal, you add in your region of interest through your assets. Okay, we've done that. So you add it. I'm going to display my region of interest. I'm going to center my map around my region of interest. Remember, 13 is your zoom level. Okay, if you go higher, 14, 15, you zoom in. If you go lower, you zoom out. And here's my clip function. Okay, clip to column, clip function. As I said, you can change this name. You don't have to say it. You can call it Roy, for example. Okay, let me just put it back, clip to column. Remember, variable names, it's up to your discretion. But just remember, keep it simple, keep it straightforward. And now variables may have variables can have the same name. Okay, have to be unique variable names. Okay, so we create our start date and end date. Okay, here we have a particular date, unlike the previous video tutorial where we have a start period, but we have a beginning and end within our start period. Here we have the first image. Okay, remember the data set starts in 2015, 6 months. Okay, so that's why I have it 2015, 6 months, and then I've got it up to to the end of last month. Okay, 2023. Now you can make it now 24/01/01 if you want to. So let's keep it there. So that's your first thing. Then obviously you generate your images. Okay, from my Dynamic World Dataset. I'm going to clip it for my region of interest. I've got my beginning date and end date. So, and obviously I'm going to filter for my my region of interest. Now, I don't know how many images there are, but there's going to be a lot. Okay, and that's why it's an image collection. It's not a one image. Now, I generate a print of this image collection, and the idea is to determine how many images are there within that image collection, and that's why I've put size there. Okay, so if I run that, I get to the information in my console. Okay, it will display like this. Okay, if I open it and I go to features, you'll see there's 1,545 images in this image collection. So that's quite and they list the images here. They give you all the images now. So if I click on one of these little arrows, you'll see that this image is on the 10th of August 2015, and obviously it's got its bands, which is water, trees, flood, etc., etc. Then if I go to the second image, this image is also the 10th of the 8th. I go to the third image, also the 10th of the 8th. Go to the third image. Let's quickly just have a look. Okay, 10th, 10s. Why are they all the 10s? Let's have a look at this one here. Okay, here we go. 2015 11th 21 15 11 21. So I'm not sure why they have a number of repeat. You see, there's a whole number of repeat images. I'm not sure why they're doing that, but anyway, it's creating. It may be different dates. We're going to have a look at it now in more detail. But the bottom line is, it is saying that there is 1,545 images within that image collection. Okay, so let's just make it wrong. Okay, so that's what's happening here. Is we're creating all the images for our region of interest for this period. We're just counting them, and that tells you there's 1,500. Okay, obviously there's our probability bands. We've done that. Remember, it comes straight from our landing page of our Dynamic World Dataset. And there they are. So we're creating that. Water, trees, grass, etc., etc. Now we select all the probability bands. Okay, so we select all of them, not just one. If you want to just select water, you most probably will just put, probability bands just isolated for water. Deselect or unselect or delete all of these ones and just put in water, and it will just display for water. But anyway, we are selecting all of our bands, and then we just display it on a chart. And what's happening in this piece of code, we're just making it a bit more nicer. It's still the same time series chart as our normal basic chart. Okay, we're just making it a little bit more neat, call it a little bit more fancy, which is not really needed, because you most probably will use it in Excel or something else where you can make it pretty. But nonetheless, so you can create a function where you just specify the details of the graph itself, the chart itself. Okay, so the line width, the point size, the color, and the label, etc. Again, these are parameters that you can make bigger and smaller, etc. So that's just the parameters of your chart. And here you actually create your chart itself, where it's the image collection, which is time series, this one here, this time series here, where we select all the bands for that particular period. So that's our images that we're going to display. The table is my region, which is table here. There's my table, which is my region of interest. So that's why it's there. My region of scale, it's normal scale point. You can change it again. And then obviously this is where you start making it now pretty in terms of bringing in your style that you have created. And there's your styles, a line style. There's your styles that you've created, the size of it, etc., etc. So then you don't have to specify for each of these lines again. You want to make it 2, 3, whatever the case might be. Okay, so there's our style for 01. We've got the name of it and the color of it, and the style will be, the line width will be 2, and the points, there will be points, which is 3, etc. And the color will be the color that is indicated there, and then we print it. So it's basically our normal standard chart or plot that we're just going to make a little bit more pretty. Okay, so that's basically what we're doing here, and that's basically that. So you run the code. Okay, remember to save now. Save and run, save and run. We're not having any images that we display except our region of interest. The rest are exactly, there's no images to display. We're just interested in the chart. Now remember, the chart itself, we're not going to create an export within our code to export the chart, although you can do that. In a couple of my previous videos, tutorials, we actually have indicated the code or the script to export charts. Oops, what did I do there? Okay, so there we go. But in this case, I'm simply just going to use the export function, or the function that will display to make it bigger, and from there I'll just export it to Excel. So it's still generating the chart. Let's give it a bit of time. It will generate. Okay, so while it's trying to generate the chart, okay, once it's generated the chart, there will be a little option, a button here. There we go. Okay, there we go, just in time. Okay, so in here it's very difficult to make sense of it. So if you press on this enlarge button, it will enlarge it, and there we go. Okay, so there's your classes of land use, land cover, or your categories of land use, land cover. Remember, each of them has a probability distribution for that specific period. Okay, so each of them will be prevalent in every single month or every single image, because they will have a probability distribution. Okay, so and then, but you can see it is very condensed because it's 1,545 images now, so that's quite a lot. Okay, but nonetheless, yeah, so this is the first chart, let me call it the unfancy chart, and then we have the fancy chart, which is this one. Okay, but to be honest, it looks the same. This is the colors that you've given is a little bit different, and it's got points. Remember, in our code we specify the line width, and there's going to be points. I can make the 0 there, and it will be no points. So you can see there's, let's make it this, there's our straightforward one, and there's our more fancy one. With the straightforward one, you take the color that the script generates. In here, fancy one, you indicate the color scheme. So that's basically, but you can see in the main it's very similar, except the labels are now a little bit prettier, etc. But nonetheless, okay. So for each image, all 9 classes will be there, but the probability distribution will be different. Okay, so in this case, you can see here in most of the images, the red and the orange, dark orange, call it the 2 reds, are the most, or are, it's got the highest probability, and the 2 reds are built and water. Built and water. So between built and water, it's cumulatively the largest land cover, land use pattern. And then we go blue would be shrubs, and then the green is trees. The bottom is that purplish color, which is snow and ice, which is obviously there's no snow here. And this light green, which is, yeah, trees, as I said there. Okay, so but again, it's very difficult to work with it. So what I've done is I go to download CSV. Okay, so you press download CSV, and you simply just save it. Okay, so once I've saved it, I then open it in CSV. Now in CSV, I just convert it into Excel. So just quickly have a look at it. There's our first, and this is a row that I've created just to give it a number. So the first image was in 2015, the 8th of the 10th. You can see there's a number of images, and they are roughly, no, they're quite different in terms of the probabilities. Not that different, and there's a total. You can see the total is the sum, and it will add up to plus minus 100 or 1, yeah, 100% or 1. Okay, so these are probabilities, total probabilities. These are the periods, etc., etc. You can see there's some images where there's no data for the classes. There's no probabilities, and that's 2015 9th images. That's the dates. After that's the date. You can see there's the 2nd of September 2015. There's 3 images, but none of that images have any information. Then on the 8th 10th day of August, you see there's quite a number of those images. There's that amount, but you can see they are a little bit different in terms of the data that they present. Now it's up to you to decide how you want to do this. Okay, so what I'm going to do is I'm just going to get rid of these empty images. So I'm just going to create quickly bare soil. I'm going to smaller somewhere, and then I'm going to go to the bottom, and then I'm just going to delete all these images. So of the 1,545, these amount of images have no content. So I'm sitting with 1,384 images that has any content. So let's just display it again from largest. Okay, so remember we started out with 1,545 images, and After there's a number of images that have no content or no data, so I deleted it, so that means I have 1,384 images. Okay, and now, so let's say I want to plot bears. I'm not going to plot them all as cumulatively on a chart, because it just, you know, it's going to confuse, or it's going to be very cluttered. So let's just do bear swirl. Okay, there we go, bear swirl. Okay, so let's go to home, and let's go to data, insert, and I go to chart, and there's the bear swirl, the chart for bear swirl. Now you can see there's certain periods. Interest, again, very cyclical. First of all, very cyclical, and that's typically because of the rainfall patterns. So that's because of rainfall patterns. But you can see there's some outliers, and to some degree you have to think carefully what you want to do with these outliers. It could be extreme weather patterns, but in general you can see there's a cyclical pattern regarding bear swirl, and that is to do with the rainfall. So you can do, let's have a look at something that won't be as seasonal. That would be bear build up. Build up won't be seasonal, but let's look and see if there's a trend in build up, to see where there's periods, yeah, when did the build up actually, you know, kicks, increase, etc. So we're going to go there, we're going to go graph, and we're going to see. So there's our build up. You can see, except there's a couple of outliers again. Let's quickly see if we can add a trend line. You can see there's a trend line. Let's increase the trend line a little bit. Okay, so let's quickly go there. Format trend line. Where's the colors now? I want a red one. I want a solid line. I want it bigger. I want it red, and I want a solid line. There we go. And let's close it. You can see if you got this trend line. Remember, trend line could be influenced by these outliers, so just be careful. But tentatively, there's definitely been an increase in build up, which we indicated in the visual. This images indeed has happened, so you can play around with that as well. Let's make it bigger. You can clear more evidently see. You can obviously lock these variables also. Anyway, so let's do a last one. Let's look at grass. Okay, now let's look at water. Because of the bare soil, let's look at water to see what if water is also cyclical. It should be cyclical because of the rainfall patterns, etc., etc. So let's have a look at that one. And okay, yeah, we'll have to be careful about these outliers here again. You can see cyclical pattern, not as extreme as bare soil, but you can see there's some cyclical pattern. If I add a trend line here, add a trend line, and it would be, let's put it a linear trend line, and then let's make that trend line also a little bit bigger. Let's do that one, and we give it a flat line. There we go. Then you can see that the water levels in the area has decreased slightly, but still has decreased, or probability of water has decreased, and as build up has increased, etc. So now you can do all sorts of things within this Excel spreadsheet that you may or may not be able to do in Google Earth Engine itself. But Google Earth Engine will give you the data, and that's obviously, you can't do any analysis if you don't have the data. So that's where the Google Earth Engine is very, very good to work with, and gives you access to this information which you may or may not have otherwise. Remember, again, play around with these numbers, dates if you want to, but general view is always more is better. So start as early as possible, end as late as possible. I said you can create singular time series for just one of these classes, but there's no point doing it, doing them all. And you can make your charts a little bit prettier, but again, that doesn't really matter because you just simply just export it to Excel, which you can work with. Okay, so that's another way of presenting the land cover data set from the dynamic the land cover use data set based on Dynamic World and Sentinel, and specifically then looking at interesting dynamics of each class within that time series, and you can do that in Excel, which makes a lot of sense to me. Okay, so yeah, that's quite neat to do as well, and I trust and I hope you enjoyed this video tutorial as much as I enjoy making these video tutorials. Good luck for your analysis and good luck for your journey, and thanks for joining me on this journey. I trust you will stay with me. We've got still a long way to go in this journey of remote sensing, and please like and subscribe, share the video, etc., etc. Welcome to communicate with me, send me notes. If there's any stuff that you want me to have a look at, we'll certainly try and see if we can play around with these things, and stay tuned. I'll see you on the other side.